Hi everyone. I recently came by this pathfinding visualizer website where you have a start node and a target node, and you create a wall or something like this, and you can choose any algorithm from these given options. Let's suppose we choose this breadth first search, then click on visualize BFS. It will show you the path of moving, how it is traversing, and then it will eventually reach the target node. And once reaching target node, it will show you what is the shortest path that you can reach to the target. So I have tried to create something within a time span of 1 to 2 hours. This is something like this, where you have the starting node and the destination node. And let's create some obstacles like walls and click on find path. It will show you that how much it has traversed in all the directions and what is the shortest path it has found using the BFS algorithm. We have solely focused on the functionalities and features, and the styling is done in a very basic manner. So let's dive into the coding part. I have opened up VS Code and we are using React because I think it would be much easier to implement this in React rather than doing everything from scratch in HTML, CSS, JS. So I am using Next.js, which is made on top of React. So let's create a route inside the pages directory like pathfinder algo.js. Do react arrow function component, name this pathfinder, and let's spin up the server. npm run dev, open up localhost. Let's go on the route pathfinder algo. It is showing up. Now let's start coding. Our first step would be to create the grid. So for that I will create area variable, which will be a type object, and let's say on x-axis I will give this 20 units and on y-axis I will give this 10 units. And to actually manage the grid I will create a state named area grid, set area grid state, and this will be initially a blank array. Now we actually have to fill the area grid and show it up on the front end. So for that I will use useEffect. Inside useEffect we will be running all the functions needed for this thing. Let's pass a blank dependency array for now, and let's import the useState as well. Now create a function create grid. Inside that create temp grid, which will be a blank array. Now we have to run nested loops. First I will do for let I from 0 to I this area dot y. So why I am doing area dot y? From 0 it will run till area dot y. Let's understand why we are doing this. I'll open up Excalibur and let's create a simple grid like this. Okay, make the color black. 1, 2, 3. I'm just making a rough sketch of a grid. Let's suppose there are 20 columns on the x-axis, and on the y-axis there are 10 columns. Let's assume the numbers. As the I is traversing in the y direction, so initially its value would be 0. Let me do this. Let I is equal to, initially its value is 0. When the value is 0, in this for loop we would be running a nested loop. For that it would traverse the whole row from left to right. Then after traversing this whole row, the value would be incremented to 1. So let me just move this, and I becomes now 1. So the position would be here, and then it would traverse this whole row again. Then the value will change to 2. So the pointer would be here, the i's value would be here, and it would again traverse this whole row using another nested loop, and it will continue till this point, whole point. And after the I has reached this point, let's say this is the 9th, as we have 10 rows here, so it would keep traversing till the last. And once the pointer, I mean this is the I, and let's suppose this pointer would be j, which is traversing through the column. So once the j has reached the end, both the loops will end. Then do I plus plus. Inside this, let's create a temp row. This will be a simple array which will be storing all these cells. So now the inner loop, let j starting from 0 to j area dot x. Let's see how the loop does process. So initially when our I is 0, let's talk about this row specifically. So then we have another variable called let j is equal to, then when we are at this position specifically, the j is 0. So we have another array that we have created. Let's do this right here, current row. This is an array. So when it is 0, it will push the 0 element. Then the pointer j moves to here, this place. The value 0 becomes 1 now. So this is the 1. So the 1 would be pushed here. Then again j increments by 1. Then it becomes 2. And this pointer moves right here. The position is 2. So this is 2. And this keeps going on and on, on and on. All the elements would be pushed till the array. And this current row would represent a single line or a single row. And similarly for the other rows as well, there would be a current row. And this single row would be pushed to an array of array which represents our whole grid. So then j plus plus. So within the cells, we need to put a simple object. Each cell would be having a specific object. Like for example, for this cell 0, 0, where it will be having a key x, which value would be 0, y. The value of this would be 0. So these represents its location. These are specific points that represents this specific cell. For example, if we come about this cell, so let me take the black color. This would be 0, 1, 2, 3, 3, 0, 1, 2, 3, 2. So this would be having this object like coming here. Its coordinates would be x, 2 and y is 3. The value of the object that is stored inside this cell would be x, 2, y, 3. Let's implement this. X would be this I, which is 0. Then y would be this j. Let's push this inside this current row dot push this object. And along with these coordinates, we also need to track other things as well. So let's see what we are trying to push in this. So we will make a property like isPath to track that if the actual cell is part of the actual path or not. So initially it would be false. Then we will track if this is the blockage or the wall. Is wall, initially it would be false again. Then we need to track if this node is visited or not. So visited would be false initially. Then we need to create something like distance. It would be infinity type, infinity. Then we are keeping track of the previous nodes. So this would be null. Let me show you something. So let's suppose we are starting from here. This is let's suppose the starting node, and this is the destination node. So what will be our shortest path? I believe this one, or maybe this one. So according to this first solution, let me zoom in. Our path would be this node, and this node. So here this is path will be true for this, and this node, and visited would be, let's suppose from this starting node we are going to this direction, and this direction, and from again each specific nodes we are going to other directions as well. So all these directions till we have traversed will be marked as visited. So all these will be true for those cells. Let's not dive deep right now, I will explain them later as well. So we will make two more properties, like is start, to keep track of if we have started from this specific node or not, and to track that if we are starting from this node we have to create our starting node states as well. So we'll create a state like const location set location use state. X would be, let's suppose we are starting from the third X position and Y third, and we have to reach to const destination set destination to use state X maybe to the 5th and Y to 7th or 8th. Okay, so in order to check that if this is the starting node, we have to do if I is location dot X and J is location dot Y, and is end. How we will check that if this is the ending node? We will check that if I is equal to destination nodes X and J is equals to destination nodes Y. And once this inner for loop is done, then we will simply push this temporary row that we created to the temporary grid. So we will do like temp grid dot push current row. So one single row will be pushed to this temporary grid. So after this outer for loop is done, we will simply update our grid, this area grid, with this temporary grid, like set area grid to temp grid, and we will have to call this function as well, like this. And if you're creating an interface and letting the users update this location, destination nodes and all, for that you can just simply use them in the dependency array, like area.x, area.y, destination.x, destination.y, location.x, location.y. So whenever any of them are updated, this function will run another time and it will create a grid again. Let's see the grid in action. So for that, inside this grid, I will add some class name like flex. We could have also used grid and grid columns and all, but I will simply use flex for now. And we have this state called area grid. We will be mapping over it area grid dot map. We get a simple row and index. I also wrap this inside braces. If you remember, each row will be holding a simple array. I will create another wrapper div with class name row. Let's close this one, div, and inside this let's create another map function. We will do row.map and it will be having a single column. Then we will do return. Now give some class names like background gray 500 for now, testing node. Let's see how the results have came out. Nothing is showing up. We probably have missed something. Okay, we have missed a return here. Let's see. Node testing, node testing, node testing. Let's replace this testing node with some actual value. Let's print this whole thing. Inside this braces, let's do JSON.stringify, print the whole column. Each column includes the coordinates, is path, is wall, visited and all. We only need the coordinates. So let's do something like, let's comment this one out and call.x and call.y, and let's put a comma. How this looks. Okay, and change this to background gray 100, and we also need to style them up. Yes, of course. So I'll do something like border, then give some border color, border gray maybe 300, then some border radius, rounded MD, padding of 1, some width like 10 or maybe 12, and same height 12. Okay, this is starting to take the shape. Let me change this, the area X with 10 and Y with 20. Let's see. Okay, this is looking quite a bit of, this is showing quite a bit of coolness. Let's indent this properly, center this thing. So I'll do like height screen, justify center items center. Yep, and in each thing, this is area grid, this should be flex as well, and flex wrap, not actually wrap but flex column wise, and then provide some gap or 2. We need to add the gaps in the columns as well, so gap of 2. Yeah, and some basic styling like keep the text size to extra small, then nothing much. Okay, this has started taking shape. And now let's add some conditional class names. For that we have to change them to backticks, select both of them, convert them into backticks and wrap them in braces. These classes will be always there, and along with them we will add some other classes as well. So for that we will have to use these, and let's check if this column is a specific wall or not. If this is a wall, we will do like BG red and some dark colors, or maybe a bit darker. If this is not a wall, then we will do nothing. So I hope you have understood this step. If this specific cell is a obstacle or a wall, we will add a brick type of color like dark red, or maybe if you want you can make this dark gray or dark slate type color. And then we will add other conditions as well inside this template literal. If this specific cell has been visited, if this is visited, then we will add a color to differentiate it, something like background yellow and maybe 500. And if this is visited, then add this, or else don't add anything. And then another condition comes here. If this specific cell is part of the path, if this is part of the path, then add a specific color. I will add something like green to make it seem like this is actual path. So add some light colors like 400, or else don't add anything specific. And hope you understand this. This is a specific node, so let me add a class name like node so to help you understand this this div is an actual node or actual cell. I mean, this 0, 0, this box is this whole div. So you can add other conditions as well to differentiate the starting and ending nodes. If the location dot x is equal to this cell's coordinates, and let's check the y coordinates as well. Location dot y is same as this cell's y coordinates. Then add background of blue, let's say 300 or 400, or else don't add anything as specific. Let me see. It will be showing that this is the starting node. So let me add other conditions as well, and along with this I will add something like text color white. In the same way, I will be checking for the destination node. Destination. If this is the destination node, then we will add background color like background green 300. Let's see. So this is the starting node, this is our destination node. Let's move forward. We might have added this accidentally. Let's remove this. Now we have to create a function to toggle the walls or the obstacles. So for that I will come here after the use effect and create a function like toggle wall. This will be having parameters, the coordinates, the x and y. So let me call this here to simplify this thing to you. After this class name, we will do on click and call this toggle wall function and pass this cells x coordinates and y coordinates. So we have received this x and y coordinates, and now let us make a simple check here. If we are calling this toggle wall function from the destination or the starting node, we should not move forward. So for that we will have to do like, if the coordinates is from destinations x and y is destinations y, or similarly I'll copy this one and paste this, replace them with location. This is the starting node and ending node. If we are toggling the wall from the starting or ending node, then we should be given this return console.error cannot move forward, or maybe some better warning like could not wall the node. We are returning from the function. If that is not the case, we will have to do update the area grid, and inside this we pass this previous grid. First make a copy from the previous grid like const new grid from spread operator and then do previous grid. Then extract the row, new row from this row given. We will do new grid, this grid one, then the row we have received like this. So it will, if we have given this specific coordinates, if we are calling this function from this specific coordinates which is 1, 1, then it will pick this specific row, this whole row. And then let's see what we are going to do after this. If you're guessing what the new row actually holds currently, this is something like 1, 0, then 1, 1, then 1, 2, this whole row itself. Now in order to find this specific column or the cell, we have to do new row, the new row, and then the y coordinates. And we have to update this one with the previous new row that we had and its y, we will keep all the properties as it is, and we will just update the wall is wall. Since we already had a boolean value in this wall, we will just simply revert it. We will do something like not, the new row, void, then is wall. Whatever we had in this is wall. If that was false, make it true. If that was previously true, make it false. Once this operation is done, then update this new grids row with the previously modified row, and then return this new grid. And now let's check this in action. When I click on this 6,0, you can see the blocks are being added. Suppose you had no intentions on clicking on this cell, but you have marked this as an wall. You can just simply click on this again and it will just toggle this like before. So let me go back in the code and add a text color, text white. This will work. Let's see. This works like wonder. Now the only thing left is writing the BFS algorithm. But before we actually write the BFS algorithm, let's see how this works. So for that I will come to Excalidraw and make a rough drawing on BFS. If you don't have any background in data structures and algorithms, let me just simply give you a brief on a tree and its breadth first search approach. So a tree will be having some nodes, like this is the parent node and these are its children nodes. Let's suppose there are 3 children of the parent and each children is having something like variable number of subchildrens. So let me connect them as well. And name them. This one is A, B, C, D, E, F, G, H. Okay. In the BFS algorithm, we traverse in levels. So let's suppose this is the level 0 and we will move one step further to its children, this and this. So it becomes level 1, level 1, level 1, and then we traverse another level like this and this to all the children or subchildren. So this becomes level 2, level 2, level 2, level 2. So first we start to traverse from this parent node. So we have a queue. Let's create a queue. Choose some other colors. Let's create a queue. So when we start to traverse, first comes the A. So this is the A. In the A we have 3 children, B, C and D. It will first move to this one. Let's suppose it will move to this in the first level. So we enter B in the next step in the queue, and this A once processed, it will be gone or popped from the queue. Then it is gone. Then B is put into the queue and all the other children like C and D. Then one phase is closed and then we will start processing from the first element, which is B. B has 2 children, which is E and F. We will enter them right here, E and F, and B will be popped from the queue. Then we get C as the first element. Then we start processing C. C has only 1 children. We will enter this in this queue and pop this C from the queue. Then we have D. D has again 1 children, which is H. So we will pop this D from this queue, and we have E, F and G, H. All these elements are leaf nodes, so we can pop them one after another. And we can simply say that all the nodes have been processed level wise. So let's implement this in the code. I will simply create a function named const visualize BFS. First, create a copy of this area grid data. I will do const grid copy, and I will do just a simple deep copy of this object. JSON.parse JSON.stringify area grid. Now let's create a queue as we have shown here. This queue, this will be a simple array for now. Queue will be a blank array. Then we will start by adding starting position to the queue. Queue.push, the starting position would be grid copy, which is our starting position, location X and location Y. So we will do location X and location Y. And since we have visited the starting position, let's mark this as visited. So we will copy this position, and it's visited, mark it as true. What is this visited? If you remember, we have created this property visited, which is initially false, which tracks that if we have visited this cell or not. So once we have visited or performed any operation on this, we'll mark this node as visited. So we have marked this one as true. Then let's create a variable to track that if we have reached the destination node or not. We will do let destination reached to false. Once we have reached the destination, we will mark this as true. We will do that later, of course. Now comes the main logic, the BFS loop. This loop will continue as long as we have nodes to explore or the queue is not empty and we have not found the destination yet. We will do something like while the queue.length is more than 0 and this destination reached is false. So for that we will just simply put a not. And inside this while loop, we will get the first element from the queue, which will be current node and queue.shift. The shift method will be providing us the first element and remove it from the array itself. Then let me show you here. For example, if we are starting to traverse from this destination, this is the starting node. So our location X and Y is this node, and our current node is also this node itself. So now we have to traverse in all the other directions. Let me zoom in a bit. In up, left, bottom and right. So for that we have to find all the direction coordinates as well. For that I will create a simple array directions. This will be having all the directions like 1, 0. What is this 1, 0? 1, 0 will be, let's suppose we are targeting this top node of this existing one. If the value of this S node is 4, 7, for the top cell, what do you expect its coordinates to be? It will be something like 4, 6. How did I actually find this coordinate? Because in the x-axis we have not changed any value at all, but we are moving to the top. That's why we have minused 1 from this y. This is coming as 6. So we have to find all these directions. Then minus 1, 0, all the combinations, all 4 combinations. Then 0, 1, and last one you will be able to expect 0, -1. Now we have to run a loop to traverse to all the 4 directions. Outside this array, we will have to run a loop const direction of directions, this array, then const new row would be current node, whatever the x coordinate is, plus direction of 0. So what is this actually? The direction specifically would be a single array inside this array of arrays. This is the direction. Direction equals to this. And the first element from this would be 1. So let's suppose the current node, if current node was 4, 7, then current node dot x would be this 4, and we are adding this 1 with this 4. So the new row's x coordinate would be 5. Similarly, the new column would be current node dot y plus direction of first. This will be adding this 0, and it will iterate over all the 4 directions. After this for loop, here comes a very crucial check. We will be checking if the new position is within the grid boundaries. So for that, we will do this new row if new row is more than 0 or not, and if the new row is less than the area permissible or not, and if the new column is more than 0 or not, and again new column is less than the area permissible or not. And apart from this area constraints, we have other conditions as well. This should not be a wall or a visited node. What this means is that, for example, if this node is already visited, once you reach to this new node, once you have reached the left node, you don't need to look for the solution in this right one, because you have already been there. You know that you won't find the solution in this node, so you don't have to look for the solution in this node that you have already visited. For that, I will do like grid copy new row new column should not be visited, and for should not we will have to give this, and in the same manner we will have to check if this is a wall or not. This cell should not be a wall either, and if all the conditions satisfies, only then we will push this to a queue. Queue dot push this one, this grid, and this new coordinates would be pushed to the queue. Since we have already stepped foot on this new node, let's mark this as visited. So we will do dot visited to true. And now comes one of the crucial things. We store a reference to the current node as the previous node for the new position. So we previously had this one, the previous node. So coming back to here, if we are currently at this specific node, we have come to this node from its right one. So for this node, its previous node is this node. You can call this as parent node or previous node. So for this left one, its parent node or previous node would be this right one. And similarly for this node as well. When we are in this node, its parent or the previous node is this one. So we have to update that as well. So we'll do grid copy or this same thing. Let's just copy paste here. Previous node would be the current node that we had, this current node. We have not changed the current node yet. Now once this if ends, we have to also check that if we have reached the destination or not. For that we will have to check that if the new row is part of the destination node or not. So we will check destination.x and new column if it is part of the destination node's y coordinate. If this is part of the destination, we will set this destination reached flag to true. and we will break from this loop. And I think this new row is not being used. Okay, we have accidentally closed the for loop here, but it will instead be ending here. So when we break from this, or we have already reached, then we break from this for loop, inner for loop, but this while loop is still running. Now we are done with our algorithm. Let's do something like, if we have found the destination, do console.log found the destination. Okay, cool. So now we have to run this visual BFS inside here. Like, let's wrap this whole thing inside a section. We'll do section, okay, never mind, section, and inside this we will do a button, simple button, and this on click would be visualize BFS function. And let's close this. Find shortest path. Let's not take care of the styling for now. Let's first see the results. Find shortest path. Let me open up the console so that we can see the results. Yeah, it has found the destination, but we have not implemented the marking, I mean the path showing and thing. So let's implement that as well. For that, inside this function itself, we will create another thing. If we have found the destination, then what we will do, okay, this destination reached, we have reached destination, then we will backtrack from the current node. We will mark the current node like let current as this thing, this grid copy destination.x, then destination.y. We have found the destination node, and from this node itself we will try to backtrack. On what logic we will backtrack? We already had this previous node, so with help of this previous node we will try to backtrack. Now we will run a while loop while current is not equal to null. Why we are actually giving this null? If you take a look carefully, you will see that previous node is by default null. While we are backtracking, there will be a one single node which will be having a previous node of null, which will be the starting point. So from the destination we are backtracking till the starting point. So inside this while loop, we will find the x and y using destructuring from the current location, and we will update the grid copies x and y, its is path to true. What is this is path? We had this is path by default false, so we are backtracking. While backtracking, we are just setting if this is part of the path, we will simply set this is path to true. Again coming back, and then the current moves to its previous node. Where is this previous node? So it will keep moving backwards. If we have not reached the destination, we will simply keep an else case, else console.error destination is unreachable. Then once we have updated this grid copy, we have to set this grid copy to our send area grid, the send area grid, which will update this area grid, and the area grid will re-render this whole grid. So after this else, we'll simply do set area grid to grid copy. Let's see this in action. I will simply add some breaks like this. This is our starting node, this is the destination node. I will add some grids like this. Let's see, and click on find shortest path. We are not able to see the path, so let me console log like console.log. This is the path node, current dot x and y. Let's see. Open up the console, click on find shortest path. Cannot read this. Okay, we forgot actually. Let me do this. JSON.stringify current. Once we click on this one, find shortest path, you'll be able to see all these console logs till the null is logged here. Let me just change some color, like from BG green 400 to 600 maybe, and let's click on find shortest path. But before that, we'll make some walls and clear this console again, and like this and this. Click on find shortest path. You'll be able to see this actually shows you the shortest path here, and this yellow color thing would be how much it has traversed so far. Let me close this one and refresh this, and let me add some random blocks like this so that the question would be much harder and we will be easily able to see the visualization. Let's click on find shortest path. You will be able to see that this is the path from the starting node till the destination node, and this is the shortest path using this BFS algorithm. I hope you liked this video. This whole thing was made within a time span of 1 to 2 hours, so we have not made any major features like smooth animations and all. This was just feature functionality and very basic styling. I hope this video was helpful to you, and if you like this video, drop a like and subscribe to the channel.